So, the intention is to do a bit of Advent code practice before 2025, and to do that, I'm doing 2019. Now, I have already done this twice. We're going to start with day one again, just go back through it, and we'll only do day one for this stream. And as I now have more time, I'm going to try and explain what I'm doing properly. So the first thing is I've organized the data structure. This is Well, I'm recording, so hopefully this catches up, and if not, I will post a video. My base data structure is I've got source and main.rs. Target is where compiled binaries with Go will go. Cargo lock we don't need to worry about. I like to do Advent of code with as few dependencies as possible, which in this case is going to be none. Later may require more. Standard library obviously is perfectly allowed. And data, we're just going to have our test data and our real data, our real puzzle input. First off, let's get to reading strings. So I've created a const, which is the base dir for the string. This is not necessarily how I would do Advent of code, but I want to show off some Rust stuff. So we'll start by creating a path. So we have a path type in the standard library. We're going to create a new path from base dir, and we're going to join to it tests, which is a folder, and day 0. Now path does everything you expect path to do, same as Python, same as Go. It will handle delimiters in different file systems. How it will handle this, I don't know. If you suddenly took this source code and put it into Linux, it will handle getting file extensions, changing them, so on and so forth. And in this case, joining, and it will use the standard delimiter. We will read that file, and we're going to use read to string, which comes straight from our file system. And let's get rid of that for a moment. And then we'll just print it out. And we're going to do a debug print on contents. Now, if I run this, it's going to fail because it doesn't know about this fs and this path, so we need to import those. So we'll import them up here. So standard path. I don't think we need path buff as well, and standard fs. I'm actually going to import the entire read to string, so I don't need to type it out every time. Now, you need to do your imports in every individual module, so we're going to have to do this again. Now, we can see that the file it's reading is this one with just 1, 2, 3, 4. And it's printed out OK 1, 2, 3, 4. And that's because read to string returns a result type. So it's a method that can fail. So we'll either return a result, it will return a result, which will either be OK and the thing you expect, or an error. This is an example of one of Rust's enums, and this is how we do error handling, and it's incredibly useful. Normally, you would error handle properly. But here, I'm just going to expect it. And what this means is it will take that result, and if it's OK, it will unwrap it and give you the string. And if it's not, it will panic with that failed to read file. So if we run this again, we can see that we now just got the string 1, 2, 3, 4. If I give it the wrong file path, it will panic. It will show us the OS code, and it should show us failed to read file. But there it is, failed to read file. So it's going to give us our failed to read file, and it's automatically going to give us the original error supplied from the read to string. Great. Now I don't want to do the entirety of Advent of code in one main.rs, so I'm going to create a new file for every day, which I'm going to call day 1. This is a completely new module, and so we need to import it using mod and day 1. And Rust will search for either a file called day1.rs or a folder called day1 with a file called mod.rs. That's the old style. Now let's just get rid of all of this because we don't need it. We'll see that again in a moment. We're going to keep our base dir here as a const, so that's available for all our children modules. And we're going to uncomment these lines that I wrote earlier. Let's just see what you're saying. 5 seconds every 10 seconds. Am I made for kids? No, that's because when I ticked the not made for kids OBS box, it didn't properly translate to YouTube. I didn't want to change it too soon to see if it decided to interrupt the stream. What we're going to do is we're going to have a function called run in day1. It takes no parameters, and it's going to return a tuple with 2 items. I don't want i32s, I want usizes. So usizes are unsigned integers that are the native size of your machine. So in this case, that should be 64 bits. The last statement in a Rust file, so long as it doesn't have a semicolon, is just your return value. You can return early if you want, but this is the same as that. For now, I'm just going to return 0, 0, and that should make this happy, except function run is private. Now, if we built this or run it, it will give us an error message saying this function is private. Oh no. Normally it will tell you how to fix this, but in this case, we just make it public. And suddenly it's all good. We have our results, 0 and 0. Perfect. So let's go and start filling things in. Now, step 1 is going to be a read. Let's call it get data. Get data is going to take a path, which is of type path. Now, we should actually really say that it's something that implements path, but for now, it's going to take a concrete type of path, and we're going to return a vec of usize. It's useful to do this for advent of code because sometimes you'll want to return some custom type. And tab9 handily is already doing exactly what we want. So we're going to, oh, come on, we don't need to do that. This is a one-line function, just dressed up a bit. So we're going to read to string. We're going to expect the error, so it's going to unwrap, and what we have at the end of this line is a string. We're going to call the lines method, and lines method is going to turn it into an iterator over strings. That type annotation is wrong. For each line, we're going to map it, and this is going to take a closure or an anonymous function. We're going to parse it, and parse, because parse could fail, we're going to expect that error. Now we could explicitly type annotate this here, and this here. However, because this is our return value, Rust can just infer the types from this. It knows that it's going to be a vec of usize, and therefore this parse must be a usize, and this collect must be a usize. So this is going to try and turn every string into a usize. We're going to expect it to unwrap the usize, and then we're going to collect this entire iterator into a vec, which is a growable array. Now it's complaining that we don't have fs. Again, I'm not going to make it fs, I'm going to make it read to string. So we'll go and add that back up. Perfect. It's also complaining that it doesn't know what the path type is, so we'll add that in as well. Perfect. And we need to actually do a borrow of this. Path is explicitly unsized, which is something covered later, so we're going to have to borrow it, but that's fine. So now in run, we can say let data path, we're going to do a path, and we're doing base dir, and we're going to join day1.txt is fine, and I'm just going to insert a join of, what did I call it? Real. Perfect. We don't know what base dir is, so we need to import it. Are you gonna? Thank you. So crate says, look in the crate we're currently in, and take base dir, which is this one here. So then we'll get data, and because we've said we're going to take a reference to a path, we need to give a reference to a path. So we now have our vec of view size. Let's have two functions. Part one is going to take data, and data obviously is a vec of view size, and it's going to return a view size. And we're going to use the to-do macro. The to-do macro tells the compiler, don't worry about this here, and this will be a runtime error when we reach it. So if we were to do, well, if we cargo run now, nothing happens. If I were to call part one with data and cargo run, we'll get a panic that says not yet implemented, which is when we come and hit this to do. So let's assign this part one. It's part one data, and we'll get part two as well. And then we'll return part one and part two. Now, I don't want it to panic, so for the moment, instead of doing to do, which is what you would normally do, we're just going to return 2 zeros. So far, so good, and this should run, right? Except it's not. You can already see the red squiggle, and we're going to see the actual compile time failure. So it's saying that something's wrong. We've used a moved value data here. So this no longer exists, it's no longer available. And the reason is we create data, we give it to the function consumes it, doesn't return it, and so it's not possible to use it again here. This is Rust's ownership in practice. Data does not exist. It's been given to part one. Part one has ownership, it could be completely mutable, it can do what it wants to it, and it's not giving it back. Gone, dropped, deallocated. The way we get around this is we say, well, actually, we just want a borrow of data. We're going to borrow in both of them just for consistency. And that says we're going to lock this in place and freeze it because this is an immutable reference, can't be changed. So nothing now is allowed to change the contents or type of data or the contents of data or where it points. Nothing, not even data itself, which owns its own data. This was a bad name. Is allowed to do anything with it so long as this reference exists. So obviously once these functions end, the references go out of scope. That would be fine. And we're going to update our functions to take a reference to a vec of view size. A reference is just a pointer, it's just a fancy pointer. A pointer that is borrow checked with the Rust borrow checker. So far, so good. There's one other thing we can do, which is that a reference to a vec of view size will actually dereference to a slice of view size. And that makes our function more useful, so long as we don't need any of the methods that come with vec, because now callers of this function could either give us a slice of view size, or they could give us a vec of view size, references to a vec of view size. Perfect. Let's go implement it. So let's read the puzzle. Elves quick learn speak. At the first go, no-go poll, every elf is go until the fuel counter upper. They haven't determined the amount of fuel. So, fuel required to launch a given module is based on its mass. Specifically, to find the fuel, take its mass, divide by 3, round down, and subtract 2. And we've got some examples. So I've already pulled those examples into the test data for day one. Here it is. Annoyingly, in 2019, they've not given us the final value. So I have worked it out. It's the 2 plus the 4, 2 plus 2 plus 654 plus 333,583. And we could naively copy all of this, change it to our test path, test data, do part one on test data, and check the value. But what we are actually going to do is we're going to do this as an official test. So in Rust, we can create a submodule within this. So the order now is our main crate, Advent of Code 2019, has a module called day one, which in turn has a module called test. So we could also have, so the path here is crate. Crate is a special word which is effectively Advent of AOC2019. Day one, test. That's the path to this module. When we do this in day two, there'll be another module called create day two test. And those can exist side by side, that's fine. And this is a special module that Rust knows to only compile under test. So test is a keyword. Is test a keyword? No, test is not a keyword. I think this could be called whatever it is, and we need to annotate this as test. Now, the compiler config test, right. So now the compiler will only compile our test module when config test is set, which is going to be when we run cargo test. We need to mark our test functions as test as well, because you might want functions for setup and destruction that aren't actual tests. The first thing we need to do is use super, and that's going to import everything from the module above. Now, children modules in Rust are allowed access to private functions, which means we can test private functions here using this method. So all we're going to do is we're going to assert equals part1, and we're going to give it, we need to give it data, so let test path equal to path new. That was fine, except for however it's come up with this random. And we're going to get the data, so we're going to give the test data, and we're going to assert that it's equal to 34,241, which hopefully is these added together, and that looks about right. I'm pretty sure it is right. I've done this twice. And it needs to be a reference to test data. Perfect. Now if we run cargo test now, this will fail. We're doing test-driven development, aren't we? Good. And it's failed because 0 is not equal to 34,241, because we're just returning 0. So far, so good. So we're going to take our data and we are going to iterate over it. So now we are effectively a for loop. We're iterating as with Python itertools, and Go doesn't have iterators. It's supremely annoying. For each number, we will map it. And we'll take our n. That's not where that key is on this keyboard. And we're going to go n divided by 3 minus 2. That's the return value. Map takes a closure or an anonymous function which has one parameter. In this case, we've named it n. The function is either here as a one-liner, or I could use curly braces to do a more complicated thing, and I could maybe do let r equal n over 3, and then we'll return r minus 2. Right. Obviously, there's no need for that right now. So n over 3 minus 2. And then at the end, so find the fuel required to launch given module, and then add them all up. And so our iterator just has a sum method. Well, iterators over numbers have a sum method. And that should be part 1 done, so we can run test. Perfect, the test has passed. So if we now do cargo run, it will tell us the answer was 3,399,394. And that was the correct answer. So far, so good. Now, we could we implement display? I think we could implement display if we wanted to format that properly, but that's perhaps a bit far. Part 2. First off, I assume your stream is still terrible. Okay, yeah, stream's terrible. Fuel itself requires fuel. and the calculation is the same. Takes mass divided by 3, round down, subtract 2. And that fuel requires fuel, and that fuel requires fuel. Any time you get to negative fuel or 0 fuel, you stop. So this sounds immediately like a recursive function. There is a new keyword in Rust for recursive to force recursive functions to be tail recursive, but I think it's in nightly. I don't know if it's in stable. Let's see, Rust. And essentially, where you have your final recursive call, you mark it with tail, I think. Sure, I saw the announcement for this. Tail call is a library. I'll look at this later. Okay, so annoyingly, in the examples here, they've not included one. So we've just got 3 separate examples, and I could go and add them together and go change the test data, but really it's probably easiest to just create another test and do these individually. So we're going to create a function called fuelCalc, and we're just going to do those. Now, tab 9, very helpfully, because I've already done this 3 times, knows these answers because here is the file for the previous one. So let's just check. 12 should be 2, or 14 should be 2. I got rid of the wrong one. 1969, which I believe is the year of the Apollo landing, is 966. Oh, I got it wrong. Good thing we're checking. Yeah, it's using the numbers for part 1. And 100,756 should be 50,346. Perfect. By the way, all this will do is it will panic if the result is not equal. Testing in Rust is a test is a fail if it panics. That's the way it signals it. So we'll have a function called fuelCalc, which is going to take a mass of the payload, and it's going to return a use size. So if we do this with recursive, we need to check that every state, the divide and the subtract, is not going to be 0. Well, fortunately, we can. Now, Rust emphasizes safety, which means that it gives safe methods for basically every built-in type. Now that's fine, but this could potentially underflow and go below 0. And as it is now, that would be a straight up panic. Rust would detect it and say, nope, not allowed. So it gives us methods to do this. So we could have checked, we could have flawed, I think, overflowing. So an overflowing sub, I think, would return it will return the overflow 0, 1, use size max. Yeah, so allow it to overflow, and then it will just say it overflowed. What I actually want to do is I want to do checked. So checked is going to tell me if this overflowed, give me this option type where we have some with the value if it's fine and none if it's not fine. Now this is adjacent to the result type, and again it's one of the other super useful built-in types. And we're going to do this for each one. So we'll do data.iter, and we're going to map on each n. And now I am going to open a function block. So we're going to do n checked div 3. Now that's going to return an option. And we could match that option, see if it's a sum or a none, and deal with those. But there is handy syntactic sugar for exactly that. If let sum, we'll now see if the result of this n checked div is a sum version of option, bind the inside of that sum to, in this case, x. So if n were 6, and we did a check div of 3, here x would be 2. If let's take that. If n is 6, x is 2. If n is 2, not in this path, okay, because we'll have got a none, which will be covered in the else. Now, in this case, if we got a none, that means we've reached a divide that gives us less than 1, and that's going to be 0 according to the rules. So whatever we leave here as our final statement becomes the end result of this block, and the end result of this block is going to be returned to map, so that's fine. If we have a value that is not none, we want to subtract 2. So exactly the same thing. You can shadow variables here, but I don't want to. Let's call it result or res is equal to x checked sub 2. Now, if it is a positive value, we're going to recurse. If it would have been 0, we're just going to return 0. So here we'll return itself plus the recursive check. And then we sum that up. Oh, I was in the wrong. I was in the wrong function. If let sum is equal to mass checked other way, that should be x, and that should be mass. Yeah. Cool. And we're going to return that value, or that value, or that value, because that is what this block evaluates to. Am I missing? Yeah, I'm missing it. You do that. Okay, no, I'm not. It's just badly indented. There we go. And we're going to map, and we're going to call fuel calc on interesting, but fine. We'll deal with that in a second. So now we can run cargo test again, and it's just going to test this fuel calc func, and that works as expected. Perfect. So we could now cargo run and get a result. That result was 5,096,223, which was correct. Now it's worth going back and redoing this, because if there were some problem with our input, I mean, if any of these numbers is below 6, I think. I should add a new one. Then we'll get a panic. And the reason is we got to subtract with overflow, because we did 5 divided by 3, which will give us 1, because it floors it, minus 2 in an unsigned is not allowed. So we should have fixed that to start with. There is no guarantee that the puzzle input would not do that. And that's going to be exactly the same. Oh, no, it's not going to be exactly the same. So now I'm going to show you how I would do this in Advent of Code. So we're going to do the checked div, and then I'm just going to expect it with bad divide. I don't know. You know what? Screw it. I'm just going to unwrap it. So if I unwrapped it, it would do the same as expect, but it wouldn't give me a nice message. So actually, I'm going to say divide. I'm going to take that, I'm going to do a checked sub on it, and we're going to expect that bad sub. We can test that again, test pass, and our results are as expected. Hopefully that was not too fast. I do appreciate that a lot of these type annotations, especially with both Rust Analyzer and Tabline fighting each other, make it quite unsightly initially. And there's a lot here, especially if you've never seen the borrow checker or the result and sum. That's not his name. The result and option enums. But they make things, especially when you're writing proper code with error handling, super handy. Right, please tell me I recorded this. I did record this. Your stream was terrible. I do apologise. 64.8% frames dropped. So I will now end this and upload the video.